Hello, and I'm going to talk some more about some of the features. I wouldn't say ideology, but it's sort of something that sets Elisa apart from other languages. And uh, the main philosophy is the same as I talked about before. It's reject as many inefficient programs as possible, reject as many unsafe programs as possible, and three, make those programs as pleasant as possible to write and work with, write and read. Um, what I found out, particularly by coding by hand and especially AI coding, is a problem that a correctness problem that AIs has a tendency to create a lot of nested if statements and stuff like that, instead of using more sophisticated pattern matching that Elisa supports. Elisa supports pattern matching that's very similar to languages like Haskell, OCaml, F Sharp, and other research languages. So I found out the solution to this problem is by again using state machines for control flow. And I call this control flow as modeling. And it basically, you can also get verification of both exhaustiveness. That means that all the states or all the options are being checked. And you can also get restrictions on how the control flow is. So we started out with no restrictions. We started out with go-tos, no restrictions. And then we went to the next step and added the structured programming, programming with blocks. This was a huge step in computing, the biggest. It's considered to be the biggest revolution in programming, structured programming. So just like Edgar Dijkstra said that go-tos are considered harmful, my statement is arbitrary control flow considered harmful, because you want to specify which states are possible, and you want to also specify the next legal state. So Elisa uses state machines where you have basically a tagged union, an algebraic data type that lists all the legal states and their payloads. And then you use something that's similar to pattern matching with recursion, where you match on a certain condition, and then it jumps to the block that it corresponds to, and then you perform some code, and then you either return break out of this branching, or you continue to the next state. So instead of having nested control flow, you have one state uh, goes to another state, executes code, and then matches on the next state. So every branch in a way corresponds to one match arm, and that gives you not only enhanced performance and increased safety, but also a sort of high level of abstraction, where you can model the flow of the program. So I think this is a feature that there are languages that have something similar to this, but those are sort of niche um, research languages or domain specific languages like data flow languages and stuff like that. So very soon I'm going to show you some code examples of how this works. Thank you.